All right. Let's see. I'm probably going to do the performance puzzle first. I'm going to go for the hardest one I made. I made two puzzles. The hard one is the performance one. So, okay, here's my puzzle. This on the exam would be a scenario. It would be written up with way too many words. So, like half a page of English, and then four answers. And sometimes all the answers have diagrams, right? So, like, you got to, with a puzzle like this, you got to take your time to understand the question on the exam. So, I'm going to try to get that part fast forwarded. So we've got a flow here at the bottom. It pulls data from a database. The data is large. So there's 5,000 records, but every record is 4 MB about. So it's on average about 4 MB. So if you do a little bit of mental math, the exam will never make you do more than like 2 multiplication questions, but you do have to do some mental arithmetic. So somebody, how big is this data set? Anybody? Come on. This is a
What'd
team
you say?
effort here.
5,000
Times,
records at 4 meg?
Uh-huh.
times 4 meg, yeah.
So 20,000.
20,
20,000 meg.
how much space is it? How much capacity are we planning on here?
Is that 2 GB?
It would be 500 would be 2 GB.
Oops. Oh yeah.
Yeah.
20.
So, and the exam will get you that way. Those little off by 0, off by 1 degree of freedom. I think we tried, because I was on the team that made some of the questions. I think we tried to make it where you, even if you made a little mental error, you wouldn't get off of the point of the question though. But it's gigabytes of data, right? Everybody got that. Gigabytes of data. All
Hang on.
right.
Yeah.
Is American and British gigas different?
Is it really?
I don't think so. I know our billions were different a while back in 1928.
Oh, that's a long time ago. You're not that old.
No.
Anyway, for the puzzle, we're pulling stuff out of a database. 5,000 records, 4 megs each. And it's a batch job. And it's got 2 steps. One step does a lookup for each record and transforms to some combined JSON, right? So it has to go do a call to something for that one step. And then the next step takes the result and it encrypts it with PGP, digitally signs it, and uploads it to an S3 bucket. So this is our process that needs to work, and it's going to be a capacity question. So this is going to run on CloudHub 2.0 on a 0.2 vCore worker. So on 3 of them. So 3 replicas on CloudHub 2.0, 0.2 vCores. And I think the test would usually tell you that those are 1 GB heap and 8 GB disk. Okay. So that's what it's going to run on. So the first question is, will this process work at all? And if not, why not? And then please share your thinking because it's a study group, right? I want everybody to see how to think through one of these. So you guys got to do a lot of the heavy lifting here. I made the puzzle. I already know the answers.
I'm gonna guess not, because the loading phase uses one of the workers.
And so tell everybody about that. What's the loading phase?
Well, the loading phase is when it takes the whole input and creates like a map to then process. And that uses your temporary file system, your temporary space on one of the machines usually, rather than like heap memory. So it does need a lot of disk. And because we worked it out that it's going to be 20 gigabytes of input, it's not going to fit on one of the 8 GB disks.
It's not. So we can't run the batch.
Yeah.
Very good. So we just hit our bottleneck. Our bottleneck is going to be CloudHub disk. That could be a question if they ask what the bottleneck is, right? So you don't know what they're going to ask ahead of time, but they're going to give you a scenario and they'll ask you something very precise like that. Is it a disk, RAM, memory, some, network? And then you'll pick the disk one. And that'll be the whole question. My puzzle is going to be harder than all the questions. So that way you get a lot of questions out of one puzzle. So before we go on, any questions about that much? or
there a
observation.
way to do like in the select when you get data from the database to do streaming where like you do it to the memory instead of the disk?
Well, we don't have we have less memory than disk, so we don't want to. But yes, when you select from the database, you can control fetch size. So it'll tell you how big the pages are that it reads from the database. So let's imagine that we are fetching to memory because that's going to be part of the solution.
Hmm.
So I'll just go there next. If anybody has any more comments, we'll go back to it. If we were going to try to improve this, we're going to have to use some RAM. And how are we going to do that? How large do our chunks need to, or what's the largest we want our chunks to be?
Well, ideally, I would probably go for the smaller one. Like again, it depends on the time. It's going to start with a 50, 500 MB chunks. So
500. So half the heat.
500 to just So
Yeah.
we have only one GB heap. So probably go with that granularity.
Yeah.
And it's going to be a trial and error. And again, depends on what else. Yeah, it's going to be a cloud hub, so you get all of them. I'd just probably start with 500 MB.
All right, good. So let's do a little math then. How many records is that?
Looking at 500 time divided by
125.
125.
125. Yeah, that's cool.
Yeah.
Yeah.
So if we max it out, it's 125. Almost definitely the exam won't want you to max it out. So the multiple choices would only show like 10, 100, 1,000, or 10,000. You know what I mean? So it'll be like, if it's something like that, it'll be 100 or, but we could put 125. But, when they ask the questions, it was part of our instructions from the exam people that all the wrong answers should be actually wrong. It's not always which is the best answer and there's two right answers. So since you know that, I'm sharing that with you that we were instructed to make every wrong answer have a reason that it's really wrong. You can use that when you're checking your answers, right?
Right.
As long as we succeeded. I don't know if everybody succeeded, but that was the instructions. So we're going to make the fetch size 125, and then that means the JDBC driver is going to load 125 records into RAM while it's querying, right? Now, Francis's observation is still the case. We're still filling up our hard drive with the load phase. So what can we do about that?
So I would never do this on Cloud Hub.
Yeah, it's possible on Cloud Hub. It is possible,
but I wouldn't do it.
Yeah.
But I understand you. I understand you don't have to.
No,
I think you need to do some tuning. Can you?
That's the reason why they mentioned Cloud Hub 2, bit hard to do tuning.
So I'm giving you that constraint. So we're going to make you do it on Cloud Hub, even though I agree on-prem would be better.
So could you start playing with some of those batch parameters, like changing the block size?
Let's go there. Let's go there first, everybody. No, you can't. That won't fix it. And let's go there and see. So you want to tell them what do those parameters do? Let's go ahead. This is for the process phase after the load.
Well, that's not going to work.
But anyway, that's a good review for exam prep. Let's go through those. What do those do?
Well, the batch size, the block size
splits.
Go ahead.
Sorry. Go ahead. I'm sorry.
No, I was just saying, well, okay, the batch block size will change the size of the blocks that are being processed at a time. So, but wouldn't that touch the load phase though? Because during the load phase, isn't it loading into blocks?
Yes. No, not exactly. the dispatch queue is the entire data set. I had to prove this to myself in a class once. So I went and
Okay.
ran a batch on my system and I looked in the .mule directory. There's a queue store subdirectory and that you can go, you look at it yourself. And I do recommend experiments like that. So run it yourself, go look in the .mule directory. You will see your whole batch go into one file. And then the blocks come out of that file. So they're used for processing, not for loading.
So when we do loading, it's always on the disk,
Always on the disk.
and then it takes.
There's an
some-
exception on Cloud Hub 1, but
Could
yeah.
could you do, oh gosh, scaling, vertical scaling? I see you have this, but could you just say,
One option is
okay,
vertical scaling. I made my puzzle not work that way because you can only the most you can get with the biggest Cloud Hub 2 worker is 20 gigs of disk. That's the max. So we're not going to get enough disk, right? By vertical scaling in this scenario.
so you would want to load chunks, right? Couldn't you just say, all right, we're going to load chunks, process this, and then load the next set of chunks? So could you just,
You're almost there. Well, how do we load
That-
chunks, guys?
Using pagination, query pagination.
Oh, I like that one. If I was to do that, query pagination, how am I going to do it? It's going to
you're
be
gonna use
data.
it? Well, I don't know if this is good. So if you use that, you could fetch based on a limit, but if you continue to keep adding to it, then that limit might get messed up.
Yeah, there's a cursors. There's a way with some databases you can do that, and you can do that in a reliable way with a database query. But we don't learn a lot of
What do you
Mule.
mean by pagination here, and how different is that from the original 500 MB or 125 records load? We are anyway picking only 125 records at a time. And what is this pagination?
Well, okay, so
With the
let's
SQL.
do that. So the fetch size of 125 is used
Right.
as the stream is being read, right? So every time it reads one, it'll read 125, and then the next one is read from
It-
RAM until it's all empty, right? So that's on the Mule side. The problem is we're just going to load them right into a file. So it's going to read the entire data set 125 at a time and put it in a file. So Nirmala's idea was to use query pagination. And if that was on your multiple choice answers, that would probably be a good move. That would work. Right? So that would work. Let's try to do it with Mule though.
You want to
Instead
use like a
of-
watermark?
Yeah, that's how that would work. That's how Nirmala's would work. So what I want you guys to do is do it with a stream. How do you do it? How do you make it stream since batch doesn't stream?
Do you want the streaming? Somebody said streaming on the database
Oh, is that
earlier.
Well, how do you do it? Because batch is going to eat the whole stream and write it to disk. So how do I make it not? How do I make what goes to disk smaller?
Can you, is it an advanced or connector configuration or something like that?
Well, I think
Go
what
Yeah.
you're saying there, Ryan, is to have a data weave that splits the input before it gets to batch.
A data weave that splits the input before it gets to batch. We could do that.
But there's
Yeah, we
and
could do that.
also the database has certain streams like repeatable streams, file streams as well.
That's all. Yeah, that's all on the read side. We need, in this case, the trouble with that approach is only that the write side, it's the writing that fills up the disk, not the reading. Since we're writing it into a disk for the load and dispatch phase, we need to make the batch job smaller. The whole job needs to become smaller. And we have 3 replicas to work with, and they all have disk. So how can we get the job split into parts that the 3 replicas can help with?
But so-
Split this into a queue.
Okay. What does that look like?
Again, a data weave to split it into chunks. and then send it to. Well, I think. Well, if it's an MQ, it's going to have to be a 10 megabyte limit, but which is a bit too small because each of them, the records is 4 meg, so it's going to have to be something like a. Well, I don't know. Is it? Can you
This is
can you have
funky.
VMQs in Cloud too?
How about a VMQ? And you better not cluster if you do that. Right? Oh, we could.
Quickly, I'm just trying to still understand what the problem is. So the select of the database that we decided it's 125 for the fetch of the number of records. So the disk space in that case is 500 megabyte. Is that correct?
No, the fetch size is going to be a
Mhm.
RAM impact. Whenever any data is read from the stream, it's going to put 125 into RAM, which we can afford that. That's okay. We have enough RAM for that, but we only have enough RAM for one page at a time, right? Because
Okay.
yeah. So now we're going to pull that much into RAM, but the
Mhm.
problem is now the batch job is going to read all the pages into disk and fill up the disk, right? So we
Got it.
don't have enough disk.
A 20 gig something. Okay.
Yeah. Yeah. So we need to read those pages into somewhere else that is smaller
Got it. Okay. Now I
or that
understand.
is distributed. Yeah.
And is that why you're saying VMQ as like almost like a holding buffer?
Mm-hmm. VMQ has back pressure too. So we want to slow the reads down so that the batch has time to finish the reads, right? Or at least they have time to be written to disk on 3 different machines. With 3 replicas, we have enough disk for all of it, barely, don't we? If you add
Yes,
it
but
up,
how are you going to make sure they're all in sync with the batch? Is
they're
that
not.
why
They don't
why
need to
we're
be in
using
sync.
VMQ?
Yeah, yeah. They don't. This problem doesn't have any synchronization. We don't have anything at the end, so we can split it all up, right? We don't need it all to be put back together when it's finished. It all just needs to land in S3 in the last step, right? So let's go ahead and what if we do this? Let's put it in a VM queue and let's move the batch job to another flow. This is the run batch flow or something. All right, and then we don't need that. Let's just collapse all. Let's clear all this stuff. Because I'm going to the next. I have another part of the puzzle, so I'm kind of getting this to there. All right, cool. So now, if we do this, let's at least convince ourselves of what changes about that, right? So now we're going to publish to a chunk queue, right? And we're going to receive from a chunk queue, however big our chunks are, right? So the question is, how big should our chunk be? Well, this is too big of a chunk. So we now want to split it up into smaller chunks. And please, let's not just do 3 giant chunks, right? Let's make them a whole lot of smaller chunks than that. So what we would do is just wrap that in a for each, right? And we determine how big the chunks are with the batch size. So you guys help me design a batch size that's going to make these chunks the right size to go to the 3 different machines. We don't want a third of the entire data set, and we don't want one at a time. So what are we going to do?
Well, you're fetching by 125. Do you want to make the chunk smaller than that? The batch size.
I like that you observe that. What do you guys think? What does the fetch size have to do with the chunk size?
I'm assuming the fetch size is you're going to get 125 records.
That's how much is going to be pulled from the database into RAM.
Right. So you said you want to put these into chunks.
So let's make chunks related to the fetch size.
Ryan, I thought when that fetch size was done, that is the data that gets pulled into the disk as well.
Well, it
Is it
won't
not?
in the first flow anymore. The first flow never lands on disk unless we make this a persistent queue and turn off clustering. Right. Now we might do that.
Okay, so the loading phase does not put the data into the disk, it's only on the RAM. So right, that's where I
The
missed it.
loading phase in this flow will put the data on disk. So however much data is in a chunk will go on disk. Right?
So I think your
Okay.
batch size, you need to divide your batch size by some size, right? So if you're fetching by
Yeah.
125 and you want your chunks to be less than that, then you can divide it by, depending on how many chunks you want. So you might want 2 or 3 at a time.
Okay.
And then how many ever chunks we want, we make that the batch size and the for each scope.
All right. So let's make a lot of chunks. And let's make them no smaller than the fetch size. How about that? So
Okay.
how big should the chunks be?
Greater than the fetch size.
Yeah, and I wouldn't probably want to do something that's like a partial fetch. I wouldn't want to do like 200 and have 75 out of one fetch and 25. You know what I mean? Isn't that
I was going to say something like a big number, like divide by 5, like your batch size is 5 or something
so
like
like 1,000
that.
or
Okay.
250 or 125? I would want to do a multiple, right? To match up with the memory fetch, and it's because of what's coming up next. So let's do like what, 750? What do you think? Or 2 or 500? Are we good with that?
So does that mean that every 500 records
Rows.
published at once to
The
the
Q. Not the MQ, the VMQ, yeah.
yeah, VMQ? And what is the reason for that? Why is it a bad idea to push everything all at once?
Let's do it with a chunk of 500 here. So now the VMQ in the second flow is going to read 501 message. And what's it going to do with them?
Gonna put it, hold on, based on what you have. I think this way it was going to put it directly on disk, but
It is still going to put it on disk, yeah. So
Yeah.
500 times 4 megabytes is how much disk?
4 GB.
2 GB, yeah. And we have 8 GB, right? So we're happy. We have room, right? And we could have done 250, we could have done 125. Those would all be small enough, right? Because we have 8
So-
GB.
so question.
Mhm.
I think the trick is VMQ is writing where? Is it just
That's the next puzzle. Where's that VMQ writing, everybody?
You
I'm
can-
thinking memory.
It's it's persistent, right?
No, you
It
got to make
can
it
be.
persistent.
It can be.
Yeah.
Yeah.
There's
Yeah.
it can. So VMQ you can. So when you can be put on a disk as well.
Now wait, let's make sure we get our problem back. 3 replicas, 0.2 vCore worker, vCore, right? So we want to take advantage of all those replicas disk and RAM. So 8 GB. So we have 8 GB disk, 1 GB RAM, right? And this process won't work if we can't use all that disk. We need to use all that disk. So what does that mean about the replicas? Do we have to do clustered or non-clustered? If we want them to share the VMQs,
They have to be clustered, right?
we have to make them clustered if we want them to share the
Yeah.
queue. Right?
Yeah.
So has to be clustered. It's not that the problem said that, it's that we realize that we have to cluster them if we want to share the queues. If we share the queues in the cluster, where will they be residing, in RAM or on disk?
On disk.
Not if they're clustered.
RAM,
Mhm.
yeah.
Oh, okay.
Clustering, it'll be Hazelcast, right? They'll all be stuck in RAM.
Oh.
So how big are those chunks?
2 gigs.
And how much RAM do we have?
8. Do we have 8 for each one? Oh, for the Hazelcast, it's 8.
Nope, for the disk, it's 8. How much
I'm
RAM
sorry.
do we have?
Yeah. So 1 gig, is it per replica or is it?
Yeah, each replica has 1 gig of RAM.
Okay,
And the chunks are how big?
2 gigs.
So they're too big. So we can't use that chunk size, can we?
Hmm.
So what are we going to change the chunk size to?
Hold
We
on.
can't
You
do
said
it.
times 2 gig, so you just have to divide it.
250.
Yeah.
250 would max it, and it probably would blow up at 250 too, because you'd use all the RAM for one chunk, right?
Mhm.
So we kind of ended up with our exact fetch size, didn't we?
Mhm.
So for each 125 now, we're going to have a chunk of 125 times 4 megabytes, which is how big?
500 MB.
500 MB. So now we got to change this chunk size. 125 times 4 megabytes, 500 MB. Now we've got a shot, right? Now we've got all of the chunks distributed to the 3 replicas, and they're going to get written to the disk for the batch job. Batch jobs are asynchronous. They don't wait. So we can't block the queue consumption by running batch jobs. So if we're going to use a batch job, which we don't have to, but I'm going to make you for this example, it's going to write it to disk, and that's it. It's going to finish consuming from the queue. So this is going to very quickly read all the chunks, put them in RAM, and write them to disk on all 3 nodes into the loading phase of the batch job. And we're going to end up with batch jobs on all 3 nodes. Right? And it's going to fill up most of the disk. Right? We're going to be filling up 20 out of 24 gigs of disk. So it's dangerous. You might want to go add another replica to this deployment, right? Because you're getting tight on disk. Right? You see why you're getting tight on disk?
Yeah, because all 3 fetches happens parallelly. So
Yeah.
1.5.
So
to
Ryan,
solve, yeah, go ahead.
so maybe we don't want to cluster. Maybe
Well-
maybe we want to do something where it's not shared and you just call 2 flows or 2 APIs. I don't know.
There's a way to do
maybe
it,
you don't
yeah.
want to share everything, but you just want to like program it in a way that one node processes this stuff, the other node processes that stuff, and it's not shared among the data.
Yeah, so
That makes
Nirmala's
sense.
idea with pagination would do that. You could make all the nodes read the data directly instead of having it fed through a queue, right? All the
Yeah.
nodes could connect to the database and pull their own data, right? And then you don't have to cluster. The problem is the only reason clustering's hurting us here is for RAM, and right now we're up against the disk bottleneck, not a RAM bottleneck. So turning off clustering doesn't help us with the disk bottleneck, right? We're using 20 out of 24 gigs of disk, and we're going to feel disk pressure probably. It's risky. It's risky. So the way to take the power off, take the pressure off the disk is to add a replica or to reduce the data size on disk, right? And you can do that with back pressure, which we're not going to do because this example, it already went to the full half hour for the example, right? So the next part of the challenge is going to have to go as a homework assignment maybe or something. Actually, I'll show you what the next part was supposed to be. Is we go ahead and deploy this thing and we run it, and we find out that the process bottlenecks on CPU because it's got encryption in it. And so we're running on these 3 0.2 vCore workers, and the encryption step starts taking like 10 minutes per file or something, because I don't know, but it ends up being a CPU bound process. So let me just ask theoretically, let's not work it out. Let's not do it, but just what do we do about a CPU bottleneck? Because we did a disk bottleneck, we did a RAM bottleneck. What do we do if it's a CPU bottleneck?
Horizontal scaling.
So you would add more replicas and take the load off of each one. The reason I would not expect that to help is that one file is 10 minutes.
Yeah.
Right?
Okay, so so the encryption is a program, so is it because it's running out of memory?
No, it's compute bound. You can tell. You go into, let's say you go into Cloud Hub monitoring dashboard and you see CPU go to 100% for 10 minutes every time it hits the encrypt step. So you know it's CPU. What do you do about it? And this gets,
I don't know. You
I
couldn't
want
give
you
it
guys, I
another
want you
core?
guys to catch what's a vCore. What exactly is a vCore?
A CPU.
And what's V about it? Why is it V instead of just core?
Is it virtual core?
So if you get 0.2 of a virtual core, what is that translating
You
to?
just need to bump it up vertically, right? You
Think
need to
so.
bump up the V cores.
You're going to get 20% of a core. and you're CPU bound for 10 minutes. So if I up it to 0.5, I can expect a very reliable improvement in CPU performance, can't I? How much performance will I get? 0.2 to 0.5. That'll give me
More
how
than
much?
double.
Huh?
More than double, of course.
More than double. Yeah. So I can expect my 10-minute delays to go down to less than 5 minutes,
Yeah.
right? By going 0.2 to 0.5. Yeah. So that's where I was going to go with this one. Is we could go bottleneck to bottleneck to bottleneck. What I want for your certification, what I want you to have as a way to approach these problems, because you're time limited on the exam, is you have to very quickly identify any performance limitation. What am I limited on? Is it disk? Is it RAM? Is it CPU? And it won't take as long as this question because you're not fill in the blank. You're going to get multiple choice. So you can rule out the answers that are not CPU if it's a CPU, or you can rule out the answers that are not disk if it's disk, right? It's a quick, you can add speed to your exam taking by ruling out what the wrong kind of bottleneck is on whatever the puzzle is, whatever the scenario is. They love to make scenario questions. They love to give you a little thing and say, okay, you're limited on, and they give you, when I was helping write them, we try to put very obvious clues in the question language. Now, this is 2 years ago. I don't know anymore if they do that, but I did. I was going to make, if it was CPU, I made it super obvious that it was CPU. You know, I wanted you to know that it was CPU. That's why I put encryption here. Encryption is definitely CPU, right?
So,
So-
Ryan, this what MCIA pretty much is all about is scenarios, development, seeing how implementation is in place, and then taking that into performance and non-functional requirements.
I think that's a big part of it. The MCIA has a very broad topic set. So it'll have high level design. It'll have see how we took some Cloud Hub information. We took some Mule runtime information. We took some flow components and what they did. For that question, we had to know batch. We had to know Cloud Hub. We had to understand, what was in RAM, what was in disk. So they like to, this MCIA is about putting all that together and solving problems. And they might be a totally different kind of problem. The one I was doing was kind of in here, performance and scalability and stuff.
Right.
Yeah, but it's definitely a mix. MCIA is notorious for being very broad. It has a lot of different topics on it. If you go down here, you can see we were just doing performance requirements. So streaming was in that one. Capacity was in that one. Yep. So I hope that was, so you guys want to do a different scenario, or did you want to dig back into that one? I don't know. Or did somebody have a different scenario you want to bring?
I like it. I like this scenario because I did a project like this a while ago and we did not use that. It would have saved us some time.
All right, I'm going to take you, I wanted to do something really different to give you a feel for, this one would work for both MCIA and MCPA. So I made a little example. Jeff's going to be recognizing it. We've been trying to use student use cases in our class this week. Or I have been trying to. So I made 2 projects at the same time. Okay, we got 2 projects. We have an existing system, an admissions app and an enrollment tracking mainframe program. And those are already connected through file integrations now. So that's existing integrations that are already there. Okay. And what we have this new project coming up where we're going to launch a student mobile app with admissions and payments. Okay. And the payments are, we have bought access to an ACH banking platform. When I made this, I was thinking of Plaid. I don't know if you guys know what Plaid is, but it's like a way that they can connect to their bank account for ACH payments. And we have Salesforce for all of the student information, like what classes they're enrolled in and how much their bill is going to be. It's all going to be in Salesforce. Okay, so that now the thing is, enrollments are also going to be in Salesforce, but we're in the middle of a parallel project where we're migrating off of our mainframe enrollment tracking system to Salesforce. So those are 2 projects going on at the same time. And I got a question for you guys, and I'd just love to hear you work out together. How do you design that? What are you going to design in the middle?
So it looks like there is a project 2 where you're trying to migrate data from enrollment data from mainframe to Salesforce, right? So is Salesforce already having some, or is a new enrollment data being created in Salesforce, or is getting created in mainframe?
Nothing new is in mainframe. We're going to retire the mainframe.
Okay, so this historical data, we need to bring it in. So any new data that we are going to create should go for enrollment, should go into Salesforce. That would fall under part of project 1. So project 2 is just a pure migration, moving the data from mainframe to Salesforce and having Salesforce expose that data to. Is admissions app going to be retired as well?
No, admissions app is very much staying around.
Okay, so the data from Salesforce has to be exposed to both admissions app and student app. That's as far as enrollment is concerned. And Salesforce already has the student information, right? All the data required for student is with Salesforce
There's developers. It's actively being added to that. Yeah.
added. So the only thing pending is the historical enrollment data to be pushed back into Salesforce. And is admissions app already integrated with Salesforce yet, or is that
No.
a new integration?
That's got to
So
be
there's
part
gonna
of
be-
part of project 2.
So you have 2 projects, right? Why wouldn't you do the data migration first before project? Well, I guess it could happen together.
Yeah.
So I'm guessing project 2 is a data migration. Is that
Yeah.
correct? And you're migrating records and files.
It's 2 parts of project 2. There's the data migration, but also these integrations won't work anymore after.
Yeah, so do you need to migrate files as well, or you just need to migrate the integration or
We
fix?
can migrate. You guys get to say how you want to do the migration. There's a good question in there about whether
Yeah.
or not we want a system API here at the mainframe.
Exactly. Yeah.
We don't. I want to hear what you think.
Do we still need to do file integrations for the admissions app, or can that be a API based integration, right?
Once the enrollment tracking system is retired, then the admissions app has to keep working with all that enrollment data. So the file, so that's another question: is do we want to maintain the file interface up
File
here?
integration,
Want to
yeah.
rebuild? Yeah.
Oh, there was
I
I know in Salesforce you can do file integrations, or you could use a file like a server that holds files. So that's what I'm asking you about files. So where are the files? Are they they're in the mainframe to the admissions, or are they on
Files
that
get
like
picked up and dropped off
server?
all the time. This is active. That's how they communicate, through files getting picked up and dropped off.
Yeah.
Oh,
Yeah,
like
I would
Yeah.
Okay.
for the target solution, I would probably put in the system API that is going to be reusable for exposing that tracking enrollment information for both admissions app and student app. So it'll be a system API that would expose that basically handle the enrollment data. Yeah.
So that's an enrollment system API, and that's in front of Salesforce.
Yeah, front of Salesforce that will expose admissions data for admissions app and also student app. Admissions app has to be modified to point to system API and get rid of file integrations. And now the enrollment API should also be used by student, and also we'll have a student system API. That
A student what?
is there any students admissions?
Oh, you mean here? So the rest of this, there's going to be other
other system APIs,
yeah,
other
whatever.
granular microservices, students, and
it'll be like their tuition and their class registrations and all that stuff. Sure.
Right.
Okay.
Yeah, and system API should take care of payment. Payment system API should probably take care of ACH banking.
So another system API here.
So how is ACH done? Is it done through file or is it done through APIs?
APIs. It's like Plaid.
Okay.
API.
I don't know. I've done some with files too. So
First data is all files. It depends on the vendor.
Yeah,
We're
all
using
real
Plaid.
time.
Hey Ryan, is it recommended to have multiple system APIs for one system, for one external system?
Yeah, so for certification, it is okay.
Mm-hmm.
For real life, you do want to discuss whether that's worth maintaining too, or having
Yeah.
one. For certification, you do want to not rule out answers that say two. That's not enough to cancel an answer out.
Okay.
Yeah, it certainly
Okay,
is.
so
So typically it's all driven by the V code because every time, at least the directions has been that we followed is try to be for microservices perspective, tries to be as granular as possible with your domains and subdomains, whether you create your system API for at a subdomain level or at a domain level. So that gives you that flexibility for maintenance. However, that's going to be dictated by vCores. But now that our licensing structure in MuleSoft is moving over from the vCores over to the flows, you still get that flexibility to see if you want to maintain the microservice at a granularity level of subdomains. So yeah, it's a give and take. It's typically it used to be driven by the cost. Of course, everything is driven by the cost, but particularly in the number of APIs you create. But the more number of APIs at granular level you have, that gives you the flexibility as a developer to not be bothered about the number of regression testings and consumer testing that you will have to involve. So, for example, if there is any changes with the enrollment, we try to simply go with an enrollment in this case, not worry about testing all those regression testing, all those student functionalities,
Right.
things like that, right? So that gives that flexibility when you go that granular level with subdomains.
So I was thinking about, I know I'm still on this because again, I did a project like this. Are we holding the files now in Salesforce, or are we going to put the files in its own file system, or are we going to
There's
put
a
it on an
question here,
FTP
yeah.
server?
Yeah, your question is good. The only reason there's
Yeah.
files now is because
Mhm.
the mainframe wants them.
Mainframe.
Admissions app is currently coded to use files. So if you make a file interface for the admissions app,
I see.
there's less work to do because you don't have to code the admissions app differently, right? But if you decide to make changes to the admissions app, then you would not need files anymore.
Okay, so you're saying it's not necessarily a document or
Mhm.
a PDF or something like that, or
No.
it's more like flat file or CSV,
Mhm.
those types of file integrations currently, and you can just put those in the
APIs.
API.
You could, yeah.
Yep.
So there's going to be a question. I would be looking in my sort of like in the multiple choices, like, is there a reason we do or don't want to modify the admissions application itself? If we do, then we can eliminate file integrations altogether and make a REST API, right? And you would probably have a experience API here, right?
Mhm.
Right.
For the admissions app, right? That's in the case that it's okay to change the admissions app, right? If it's not okay to change the admissions app, you would still make an admissions experience API, right? But it would be a file integration, right?
Mhm.
So you're gonna just you're just gonna pretend like you're the mainframe, right? With files. And that's not as good, right? But the benefit there is that it does not require changes to the admissions app. So it depends what whether the question says something about do we want to or not want to modify the admissions app, right? It's a good question, right? So that would be something I would be looking for in my context of my question. Right. Do we want to use REST or files up here? What about
Yeah.
process APIs? Anybody see any
Yeah.
process APIs?
Yeah, I was going to. So yeah, so there is any use case for process API between that would play a role between student and payment. Again, depends on how we gather the data. So for example, if you have to do a payment API, you need to have some student information and whatever the classes they have enrolled with. So probably
There's
that
certainly
payment
going to be
API.
lots of complexity because after
Yeah.
after we collect a payment, we have to mark their account that they've made their
Yeah.
payment, and to send them a
Yeah,
bill.
so you'll have a process API definitely in place, at least minimum of one. Let's see.
Ryan, what are
Um,
your thoughts on the new licensing where I don't know if they are moving away, but they're introducing that new, the pricing is based on a flow, not.
Yeah, yeah.
So in that specific scenario, would you take into consideration that, if there are any licensing limitation, maybe just an experience API would just take care of the flow so that you're not introducing process layer and experience layer and adding more flows in that case?
Yeah, because the new pricing model is probably going to end up on the certification someday. So it's definitely worth I don't understand it well enough yet to know how they count flows, but you're right. Flows are usage-based, usage metered. So however many flows you have, and it's multiplied by environments. So yeah, that might limit the layers that you put in there. That would be it for the certification. I would think money is a constraint, just like performance is a constraint, just like delivery time is a constraint. So if licensing is going to be relevant to the certification question, they're going to put it in the question. They're going to say what the license is. You know what I mean? It's not going to be a hidden decision criteria. It's going
But
to be
with this model, isn't that taking away from like the main value of MuleSoft, which is like reusability and having this like a process layer that kind of separate business logic from system logic from experience logic?
yeah, that there's always been, yeah, and even still there's going to be more some friction between the best way to design things and the MuleSoft billing model.
Yeah.
I agree with that.
I thought it was endpoints rather than actual flows.
Sorry?
I thought it was endpoints. It's a combination of endpoints, payload size, and number of transactions.
I think
I think it's flows.
I think different customers don't have the same model. I'm a customer and I have the flows model, so I can show that.
Yeah, I have flows as well.
So here's my license down here. This is an automation starter package is what it's called. So I have 30 flows, and I don't know what makes them public. I don't know what that means, public flows yet, but I can tell you that right now I'm using 16 of them for 3 applications. Right. I've got a little meter here that shows I've got 3 applications we used for my M unit class. Madonna was in there. We have 7 flows, 7. So I used half my license. Right. And that's
Yeah, because I don't think automation bundle is like really good for somebody that's going to do a lot of classic MuleSoft projects, you know? Because if you're doing like API led, you're going to use a lot of flows doing API led.
well, a lot of in the dozens for sure. I did just by my normal code. Yeah.
Yeah.
I didn't tune my code for that. But
Are those flows got inbound endpoints? I mean, is the difference between public and private flows? I'm guessing that the 7 have inbound bits
I
like
think they're with event sources.
Yeah.
That's a good question. I don't know the answer yet. I'm still learning myself.
I think public endpoints means the input source is populated.
Yeah. So I don't think that this is in scope for the certification yet, but I would expect it someday to come in scope. So that would definitely be worth looking at. I'm running out of time, everybody. I hope we got some mileage out of this API led one. And we'll be doing, I suppose I should go do the rest of the slides, right, Whitney? So let's just get the study group wrapped up. We have a class starting up in a couple of weeks for professional integration with MuleSoft. It's Integration Quest's kind of hands-on practical MuleSoft developer class. So send your colleagues who you want to learn how to do MuleSoft the right way to our class. It's a couple of days a week. It's a 2-day-a-week evening class with a little bit of homework. So that's the way we've designed it. It lasts for 12 weeks. So again, go ahead and there's a link there to send people to it. You can always find it in our classes page on our website. We also have RPA labs. So I didn't get a chance to talk much about automation, but RPA is the automation product by MuleSoft. So we went out and bought that automation bundle you just saw, and we allow you to use it if you want. So you can go get a lab and try doing RPA yourself for learning purposes, that's on the website. And please, we've already had 2 of you give us your success stories. We like to hear it. We like to put it on our website. We like to feature the people who are in our community are learning and growing, because that's what we're here for, is for people to continue to get better at doing software well. So our next study group is in 2 weeks from now, May 3rd. We're going to do a data weave study group. So bring your hardest data weave challenges. We love data weave here, and we're going to spend some time on data weave in 2 weeks. And if you want topics, send us what topics you want. And bring your buddies. You know, we definitely, I feel like I got a lot out of just this one study group with you guys. So your participation and your friends are welcome to join our study group with us. So thanks for coming. We'll see you at our next study group.
Quick question. Are you guys planning architectural, I don't know, courses, MCIA, MCPA?
Yes. We're
Okay.
working on the curriculum is so much harder to build. Oh my gosh. Because we do all our own original curriculum. So like we are taking a long time to build the curriculum. We're probably going to have textbooks, is what I think we're going to do, is real normal textbooks.
Okay.
For
Hey,
that.
Ryan, you know I could write you a textbook, right?
That would be great. I'm actually using the ones I've already identified are written already on Amazon, like enterprise integration patterns, you know. Well, but
Yeah,
maybe
that
we
one.
would need to have a textbook. But yeah, that's definitely that one is Madonna is taking longer to get ready. But yeah, probably late this summer we're going to start an architecture class.
Okay. Awesome.
Yeah. So, all right.
Oh, I wanted to say I'm sending out a recap of everything. You guys should have been getting our emails. It's through our Kajabi site, and there'll be a link to the video, as well as more information about the course and RPA lab. So if you're not getting our emails, then you should probably go subscribe to our website and subscribe, and you'll be able to get those emails from Kajabi and get the notes for today.
Awesome. Thank you.
All right, guys. Till next time.
All
Cheers,
right,
everyone.
you did a great job, as always.
Thanks.
See you after the
Thank you.
weekend.
Everybody
great
enjoy the
weekend.
rest of your day.